This is the first and only section of chapter 4, which is on combinations of random variables. So we'll start by letting x and y be two independent random variables. And what we're going to do is combine these random variables. So for example, if I want to find the mean, the combined mean of these two random variables, then I will add the mean of the first random variable to the second. And if I want to find the difference of those means of those two random variables, or do subtraction of some sort, then it's the mean of the first random variable minus the mean of the second random variable. And that all makes sense really. Now with the variance, if you want to find what the variance is when you combine these random variables, you add the variances together. Now this is the one you need to watch out for. When you want to find a difference between the variances, or you want to do the first variance minus the second, then the actual working we do is the variance of the first plus the variance of the second. So I'm just going to highlight that because you could be tempted to subtract them, but you don't subtract, so not minus. So that's where an issue could come with these types of questions, is that you end up subtracting the variance when you want to find a difference of the variances. We always add here. Now we can extend these rules and work out multiples of the mean. And I'm sure there's a rule that's very similar to this in discrete random variables in further stats 1. But again, these rules here are fairly straightforward. Multiply the mean of x by a and then add b times the mean of y. And the same thing with subtraction. Now with the variance, we multiply by this number, let's call it a squared and b squared. So when you're adding here, you add the variances. And just with this rule over here, when we subtract multiples of these random variables and want to work out the variance, we still add here. So I'll just highlight that. So that's going to be a common theme in this chapter, that when we've got these variances here, we're not going to subtract. So you're always adding the variance, even when we're finding the difference between multiples of the variance here, or just the difference between the variances here. Okay, so we're now going to extend these rules to normal distribution. So we're going to say, right, let x be normally distributed with a mean of mu1 and a variance of sigma 1 squared, and the same here, y is going to be normally distributed with a different mean and variance. So first of all, if we add multiples of these random variables, then the normal distribution of that is going to have a mean which is a multiple of the mean of x plus that multiple of the mean of y. So we can see that here. And we're going to take that multiple, square it. We multiply that by the first variance and add it to that multiple squared of the second variance. So it looks quite complicated, but actually we're just doing some multiplication and adding here. And when we come to multiples of these random variables and we're subtracting, the only difference is, well, we subtract here, which sort of makes sense. That's the same as these rules here, which we had before. But the variance, just like we did before, to find this new variance, we're going to add the variances multiplied by these multiples squared to get this new variance. And again, that sort of tallies with these rules that we've done down here. So even if this is a minus, the variances still get added together. Then lastly, when we've got more than two random variables, let's say we've got n lots of random variables, and they're all independent, but they all have exactly the same distribution, in this case a normal distribution. So this little I here is just saying, right, you know, x1, x2, x3, x4, all the way up to xn are all normally distributed, and they've all got exactly the same mean, and they've all got the exactly the same variance. So we've got all of these random variables, they're identical in their distributions, their mean and their variances. Then if I add together all of my random variables, these identical random variables, which is what this means here. And I want to work out what is the mean and variance of the distribution of n lots of these random variables. It's still a normal distribution, it's still normally distributed, and the mean is going to be n times by the mean of each individual one, which is the same, and then we multiply the variance by n. So let's say, for example, I had 10 independent random variables, and they all had the same mean and all had the same variance. Then the distribution of those 10 independent variables would be 10 times by the mean of each individual one, and n times by, or 10 times by, the variance of each individual one. And basically that's just an extension of this rule here. Yeah, so rather than having 2, we've got n lots, and we're adding n lots of their means together, and the same with the variance. Rather than having 2 lots, we've got n lots, so we're going to have n lots of the variance. So it's just an extension of these two rules that we've got here. Example 1. If x is a random variable with the mean equal to mu1 and the variance equal to sigma 1 squared, and y is an independent random variable with a mean of that is mu2 and its variance is sigma 2 squared, find the mean and variance first of all of x plus y. So we're going to start by using this rule here because we want to find the mean of x plus y, the mean of x plus y, and the rule says we want the mean of x plus the mean of y. So the mean of x is mu1 and the mean of y is mu2. So that's basically it. That's going to be our final answer for part A. And for the second part of part A, we want to find the variance of x plus y. And for the rules, that's the variance of x plus the variance of y. So we have the variance of x, and that's sigma 1 squared. So we'll just write that down, sigma 1 squared. And then the mean, or the variance of y, is just going to be sigma 2 squared. So that's all pretty straightforward. We'll go into part B. Our distribution now is x minus y, or we're doing the random variable x minus the random variable y. So the rule that we're going to use is that the mean of x minus y is the mean of x minus the mean of y. In this case, that's going to be mu1 minus mu2, so that's all we have to do. And we now want to find the variance. So this is where we need to watch out. The variance of x minus y, remember, is the variance of x plus the variance of y. So don't subtract, we still add, even though we're subtracting our random variables, and that's going to be sigma 1 squared plus sigma 2 squared. So just a reminder again, even though we're subtracting our random variables here, we still add the variances. So this second part, finding the variances, is the same regardless of whether our random variables get added or subtracted. Example 2. The independent random variables x and y have distributions x, which is a normal distribution with mean 5, variance 2 squared, and y, again normally distributed, mean 10 and variance 3 squared. And in part A, what we need to do is to find the distributions first of all of A, which is x plus y, and B, which is 9x minus 2y. Now when a question asks you to find a distribution, that means you need to have an answer of this form. So some distribution that we're given is normally distributed, and we need to calculate what the mean and the variance is of this distribution. So our job in this part of the question is going to be to work out what are these values here, but for A. So I've got the rules written down here. I've just compacted them by using plus or minus, and you can see here that the variance has always got plus. So for part A, the distribution of A. So A is distributed and it's also normally distributed. And we're going to be using this top rule here. So what I need to do is to add the mean of X and the mean of Y to get the mean of A. So that's going to be 5 plus 10. We'll simplify all in a moment. So 5 plus 10, that gives us the mean. And then to find the variance of X plus Y. So going down to my rule here. So I'll just add these variances together. So it's going to be 2 squared plus 3 squared. So we'll just simplify that, work it out. So it's going to be a normal distribution with a mean of 15 and a variance of 4 plus 9, which is going to be 13. Now remember, if you had another bit of the question that was asking about the standard deviation, then it would be the square root of 13. So that's the first part of part A. So the second part of part A, B is going to be normally distributed. We want to find the mean of this normal distribution. So we're going to be using this rule down here, where A is 9 and B is negative 2. So we want to do A times by the mean of X. So 9 times by the mean of X, which is 5, plus, because that's what the rule says down here, B times by the mean of Y. So B is going to be negative 2, and it's going to be negative 2 times by 10. So plus negative 2 times by 10. So that's going to give us the mean. Now to find the variance of this new distribution, I need to do A squared times by the variance of X. So it's going to be 9 squared times by 2 squared. So 9 squared times by 2 squared, not plus, times by 2 squared. And then plus, we'll always plus the variance, even if this is a minus here. B squared, so it's going to be negative 2 squared, times by the variance of Y, which is 3 squared. So we've got plus negative 2 squared times by 3 squared. So we'll work out what those numbers are. So here we've got 9 times by 5, which is 45, minus 20. So that's going to be a mean of 25. And then for the variance, we've got 9 squared, so we've got 81 times by 4, plus, and then this is going to be 4 times by 9. And that gives us a total of 360. So 360 is the variance. Square root of 360 would be the standard deviation. Okay, let's move on to part B. And it says find the probability that B is greater than 30. So this is just a nice easy one. We can do this on a calculator. I'll just draw out the distribution so you can see what it looks like. So this is our distribution of B. You don't really need this diagram. And we've seen that B has a mean of 25 and it's going to have a standard deviation of square root 360. And we want to find the probability that it's less than 30. So we'll do this on our calculators. And I've realised it should be greater than 30. I've just shaded less than 30, so let's correct that. So we'll put this back on here and we'll shade the correct side now. Greater than 30, there we go. So using normal CD, a lower value of 30, upper value, just put 9999999, mean of 25, standard deviation, square root 360, and to 4 decimal places, I've got the probability that B is greater than 30 as equal to 0.39607, so we'll call that 0.3961. So 4 decimal places or 3 significant figures is fine for that. And then lastly, part C, it says the independent random variables y1, y2, y3 and y4 all have the same distribution as y. The random variable z is defined as the sum of these 4 independent random variables that all have the same distribution. And what we need to do is to find the mean and the standard deviation of Z. So first of all, this, what we've got written down here, with Z, is basically saying that Z is equal to y1 plus y2 plus y3 plus y4. All of them have the same distribution. Now we can use that rule that says, right, if we've got these identical distributions of these independent random variables, then we just do n lots of the mean and n lots of the variance. So the original distribution is y, which has a mean of 10 and a variance of 3 squared. So Z is also going to be distributed, and n in this case is 4. I've got 4 lots of this distribution, so 4 times the mean and then 4 times the variance. So that will give me that Z is normally distributed with a mean of 40 and a variance of 4 times 9, which is 36. But we need to be careful because the question says that we need to find the mean, which we can write down, and the standard deviation of Z. So the mean of Z, so we could write that either as mu Z or E of X, or E of Z, sorry. So the mean of Z, we could write it as the mean is 40, and the standard deviation, so we'll actually use the standard deviation symbol, is going to be the square root of 36, so that will be 6. So you got answers there, mean of 40 and a standard deviation here of 6. So do watch out for that when you get standard deviation and not variance. So example 3, the independent random variables x and y have these distributions here. We've got one for x, normally distributed, mean of 25, variance of 6, and y, again normally distributed, mean of 22 and a variance of 10. Find the probability that x is greater than y. So we're going to start with a little bit of algebra to help us out. So first of all, x greater than y, probability that x is greater than y, that's going to be difficult to do. If it was a discrete random variables question, you could probably do it because you've just got a few discrete values, but with a continuous distribution, that's going to be tricky. So we'll change that to x minus y is greater than 0. Now I know how to deal with x minus y, and I could then find a probability that it's greater than 0. So in our question, we're being asked to find a probability that x is greater than y. What we're actually going to do is find a probability that x minus y is greater than 0. That's something we can do. So the first thing we need to do is to work out what is this distribution. What's the distribution of x minus y? Well, we're going to work out first of all the mean of x minus y, and that's the mean of x, 25, minus the mean of y, 22. So x minus y has a mean of 3, so I'll just write this down here, x minus y, normally distributed with a mean of 3. Okay, now you can assign this to another letter. You could say x minus y equals a or something like that if you want to. I'm just going to leave it. And then I'm also going to work out the variance of this new distribution, x minus y. And that's the variance of x, 6, plus the variance of y. Maybe you plus them together. So it's 16. So this new distribution has a mean of 3 and a variance of 16. And what I want to do is I'm going to find the probability that this distribution is greater than 0. Now I'm going to draw a diagram, you don't need to. So this is the distribution of x minus y, normally distributed. It has a mean of 3 and a standard deviation of the square root of 16, which is just going to be 4. And I want to find the probability that this distribution is greater than 0. So if I put 0 here, shade the correct side, I'm basically trying to work out this area here, and just use my calculator. And using normal CD and a lower value of 0 and an upper value of any large number, as long as it's more than 5 standard deviations away from the 3. That gives me a value of 0.77337. So I'll round it to 4 decimal places. So 0.7734, and that's 4 decimal places. So 4 decimal places or 3 significant figures is fine. So on some questions, it's helpful to maybe rearrange the probability you're trying to find so that it becomes either the sum or the difference between these two distributions, and then we can use our rules to work out the mean and the variance of this new distribution. Example 4. Bottles of mineral water are delivered to shops in crates of 12 bottles each. The weights of bottles are normally distributed with a mean weight of 2 kg, so just underline that, and a standard deviation of 0.05 kg. The weights of the empty crates are normally distributed, and so are the weights of the bottles, with a mean weight of 2.5 and a standard deviation of 0.3 kg. Assuming that all random variables are independent, find the probability that a full crate will weigh between 26 and 27 kg. So let's assign some letters to these distributions. And I'm just going to use letters that make sense. So the bottles I'm going to call B for bottle, and I've got these 12 bottles here, so I won't write all 12, but basically what we've got is these 12 independent random variables that all have an identical normal distribution, the same mean and the same variance and standard deviation. So we can do a calculation to work out what the mean of the sum of those 12 would be. So we're going to be using this rule here. So the distribution of the sum of all 12 of these, let's just call that B, is going to be normally distributed. N is 12 because I've got 12 bottles. 12 times by the mean of each bottle, which is 2, and then 12 times by the variance of each bottle. Now that's going to be 0.05 squared because we've got the standard deviation of each bottle. So these 12 bottles will have a mean of 24, and 12 times by 0.05 squared gives us a variance of 0.03. So that's for the 12 bottles. And for the crate, I'll use C for crate. We only have one crate, so that crate, its weight, so the empty crate has a mean weight of 2.5 and a standard deviation of 0.3, so a variance of 0.3 squared. And what we want to do is to find the weight of the 12 bottles, or the distribution for the weight of the 12 bottles in the crate. So that's going to be B, that's my 12 bottles, plus C, plus the crate. So B plus C, the bottles plus the crate, is going to be normally distributed. Its mean is going to be the mean of the 12 bottles. So we're just using the mean of X plus the mean of Y. So it's going to be 24 plus 2.5. 24 plus 2.5. And for the variance of the 12 bottles plus the crate, that's going to be the 0.03 plus the 0.3 squared. So 0.03 plus 0.3 squared. So doing the calculations, what we'll have is bottles plus crates, normally distributed, with a mean of 26.5, and then the 0.03 plus 0.3 squared is 0.12, so that'll be the variance. Okay, so we found this new distribution. Now what do we want to do? We want to find a probability that a full crate will be between 26 and 27 kilos. So again, I'll do a diagram. I'll probably rub this out straight away just to see what we're doing. So this is a distribution of B plus C, the 12 bottles, plus the crate. This has a mean of 26.5 and a standard deviation, which is going to be the square root of 0.12. And we want to find a probability that the crate and the 12 bottles weigh between 26 and 27 kilos. So we'll just write that down. So the probability that B plus C is basically greater than 26 and less than 27, using our calculator, we get 0.85108. So we'll call that 1 to 4 decimal places. Okay, so that's part A. And we'll move on to part B. 2 bottles are selected at random from a crate. Find a probability that they differ in weight by no more than 0.5 kg. Okay, so what does that mean? If I pick any 2 bottles, let's say B1 and B2, to work out the difference in the weight, that would be B1 minus B2, so that's 2 random bottles that I've picked. Now we want that difference to be less than 0.1. Now it could be that this first bottle here is the heavier one, so it'll be a positive answer, or it could be that bottle 2 is the heavier one, so we could get a negative answer. So we want that difference to be greater than negative 0.1 as well, because we don't know which one we're going to pick first. Are we going to pick the heavier, slightly heavier bottle first, or the slightly lighter bottle? So we need to account for both of those scenarios. So now we want to find the mean and variance of this new distribution, B1 minus B2. So again, we could assign it a letter. I'll just write it as B1 minus B2. It's going to be normally distributed. And then to find the mean of this new distribution, it's going to be the mean of B1 minus the mean of B2. Now they both got the same mean because he's identical here. So that'd be 2 minus 2, so it's going to end up being 0. And then the variance of this new distribution, well, it's going to be the variance of each bottle. But remember, we add them together. So the variance is going to be 0.05 squared plus 0.05 squared, or times by 2. So B1 minus B2 is normally distributed with a mean of 0, and then 0.05 squared plus itself gives us 0.005 as the value of the variance. And what we want to do is to find out the probability that this distribution is between negative 0.1 and plus 0.1. So again, I'm just going to draw the distribution here. The distribution of B1 minus B2, like this. The mean of this is 0. And its standard deviation is going to be the square root of 0.005. And I want to find the probability that it's between 0.1 and minus 0.1. So I want to find this area here. Again, I can use my calculator for that. And calculator says 0.84270. So we can round it to those 4 decimal places here, 4 dp. And that is going to be that probability. Right, okay, let's move on to part C. Let's create a bit of space first. So here what we need to do is to find the weight M that a full crate should have on its label, so that there's a 1% chance that it will weigh more than M. Okay, so first thing is that this weight M is a full crate. So M are our 12 bottles plus the crate. And I think I said before that I was using B to stand for these 12 bottles and C to stand for the crate. So that means that M is normally distributed with the values that we had for the mean and the variance before. Now I believe we had a mean of 26.5. That came from doing 12 times by 2 plus 2.5 to 12 bottles, 12 times those means plus the mean of the one crate. And then the variance of the full crate, well, that would have been 12 times by 0.05 squared plus the 0.3 squared, and that gave us a value of 0.12. So this was from part A, so you could always rewind and go back. Right, and let's draw a diagram, that may help on this question. So I've got this M, which is normally distributed. I have the mean of M, which is 26.5. I have the standard deviation of M, which is going to be the square root of 0.12. And the question says we need to find a weight. So we need to find a value on this scale. So it's probably like inverse normal, that a full crate should have on its label, so that there's a 1% chance that it will weigh more than M. Okay, so what does that mean? It means that this area here needs to be 1. And we need to work out what this value of M is. So that's going to be inverse normal. And when we use inverse normal on a calculator, we're going to have an area. Remember, if you just got a FX991EX, we want the area from the left. Over here, if you've got a CG50, you can tell it left or right tail. So on our calculator, area from the left is going to be 99%. The standard deviation that we type in, that's going to be the square root of 0.12. And the mean that we're going to type in is going to be 26.5. So if we type in inverse normal, we get a value of M, which is 27.30587, and so on. So maybe we'll give that to 3 significant figures. 27.3 kg. That's 3 significant figures. So that's how we do that one. So sometimes you get questions where you need to use inverse normal, and I find that if you draw a diagram, it makes the whole process much easier, because you can physically see what it is that you need to work out much easier than just trying to read it and go straight into the working. So you should now be able to do exercise 4A on pages 95 to 98 of the textbook, and I've just put here the rules that we used as a quick recap, but this is also on the first slide.